Hi, I'm Jay Phelan. Let's learn some biology. We've been looking at the nervous system and in particular the synapse and how it works. I want to talk now about how drugs can interfere with the typical functioning of synapses in ways that can have some predictable effects. And sometimes these are about recreational drugs, other times they are about pharmaceutical drugs. But let's take a look at a few of them. We've seen previously that at the reward centers of the brain, dopamine is the neurotransmitter that is getting released. When dopamine is released, binds to dopamine receptors on a postsynaptic cell and fires. We experience this as pleasure. It can be intense pleasure. Dopamine isn't the only neurotransmitter that is associated with pleasure. There are other neurotransmitters as well, and an important one of these is serotonin. Serotonin occurs in various parts in the brain, in your digestive tract, a variety of places in the body. And we see that it has a lot of different effects, but these include influencing your appetite, influencing your need for sleep, influencing your feelings of anxiety, your mood. Typically, if we were to make a broad generalization, it tends to make you content and satiated when you are getting serotonin release. So think about that. Do you like this neurotransmitter? Makes you feel content and satiated? We do. Would you like to have more of it? Well, researchers thought about this. They thought, what if we were to block the reuptake receptor for serotonin? So serotonin is being released in response to behaviors that are enhancing your fitness, gets released from the postsynaptic cell, diffuses back. Some of it gets broken down in the synaptic cleft. Some of it gets bound to the reuptake receptor, brought back into the cell and recycled. Well, if we block reuptake, serotonin is going to sit in the synaptic cleft longer. It's going to float back again. It's going to hit the postsynaptic cell, bind to the receptor, and trigger additional response. What's going to happen? Well, what we find is that in many cases, this can alleviate depression. It can cause people to have increased and persistent feelings of contentment. This is, in fact, the strategy behind the drug Prozac, as well as a host of other drugs like this that are used for treatment of depression: Zoloft, Paxil, Luvox, Celexa. It was a design of the drug manufacturers to try to do this, to tinker with what's going on in the synapse so that we could alter the mood of people who were experiencing debilitating depression. There's another question for you that turns out to be related. Can you imagine someone paying money to have a doctor inject what is literally the most toxic substance that humans have ever discovered? Well, since I'm asking the question, the answer is yes. There are people, in fact, quite a few people, who pay money for this. It's because it's Botox. Botox is a chemical produced by a bacterium. It's called botulinum toxin, and it's produced by the bacterium Clostridium botulinum. It's produced, has nothing to do with humans. It's produced as a defense, a chemical defense. But if humans get exposed to this chemical, it can cause botulism. This is a life-threatening illness, and it's lethal at 2 billionths of a gram per kilogram. This is why I say it's the most toxic substance that humans have ever discovered. Getting back to Botox, how does it work? Well, here's what happens. A doctor will take a very, very, very small dose of Botox, and they will inject it into parts of your body, say your face, where there are muscles. And they inject it so that it gets into the terminal button where you have a motor neuron meeting up with a muscle. Now think about this. Wrinkles in your face, these come from muscle contractions. Typically, it's useful. We can convey emotions. We can express things we want to communicate to other people this way. But over time, also, we end up with wrinkles. And these wrinkles are influenced by muscles that are contracting. So when you inject Botox into the synapse where you have a connection between a neuron and a muscle, it gets in there and the toxin breaks down a protein called SNAP25 and a few other proteins that typically are required in building the scaffolding that connects the vesicle that has the neurotransmitter in it to the presynaptic membrane. So remember, when an action potential comes down a neuron, it causes the vesicles to fuse with the membrane and dump the neurotransmitter in the synapse. Well, Botox, by blocking this SNAP25 protein, doesn't allow the vesicles to fuse. And so even though there's been an action potential, we don't get any release of neurotransmitter. Because no acetylcholine is released, the muscle's paralyzed. Nothing happens. And in this case, what it means is that what was causing the wrinkle goes away. Here's the kicker too. It can stay in the terminal button for 2 to 4 months, just blocking release of acetylcholine. What we see then is that wherever it's been injected, it might be around the eye or it might be around the mouth, it causes much smoother skin. If you look, you might at first, you hear about this, you think, oh, that's terrible, that's gross. But if I just show you a picture, so look at this picture, we have someone before and after, would you rather look like the after or the before? People don't generally like having wrinkles, and this guy looks exactly the same, except that the wrinkles are gone. He looks a little bit younger. He looks just a little bit better. This is why people do it. Here's Gordon Ramsay, and he professed to never want to do this, and his friend Simon Cowell kept pestering, oh, you should get it, it'll make you look better. And he tells this story about how he was asleep at home on his couch once, and while he's asleep, his kids, who were very little at the time, were taking these coins and they were sticking them into the crevices, the wrinkles that he had, because the wrinkles were so deep. They thought that was really funny, and it made him feel very sad. He finally decided, all right, I'll give it a try. And so you can see here a before and after picture, and same thing, it causes the wrinkles to be less pronounced. Here we see an actress who had Botox done. This was a news story where some mother was having the doctor give injections of Botox into her 8-year-old daughter's skin. The mother said she didn't like the way certain wrinkles looked when the daughter would laugh. Anyway, Botox is a huge industry. It's about $5 billion a year. It's one of the most common cosmetic surgeries that is done. Let's look at some other drug effects that we see. LSD, referred to as acid. This is a drug that gets to synapses in the brain, and it binds to serotonin receptors, causing them to be more sensitive. Think about that. Serotonin typically is making you feel content. If you have a chemical that can bind to the receptor so that a smaller amount of serotonin will still cause sufficient stimulation to have the signal get passed on, what's that going to cause? It's going to cause increased serotonin activity. So we see that's part of the way that LSD has its effect. Or crystal meth. This is maybe the most addictive of all drugs, and you might be able to understand why here, because when crystal meth gets into synapses, it stimulates dopamine release. So essentially you turn the nozzle of dopamine release way up, and you stimulate serotonin release. So you turn the nozzle of serotonin up. So you've got your contentment neurotransmitter, you've got your euphoria, dopamine, pleasure center neurotransmitter, and you're turning both of them up higher. This is why when people do crystal meth, the likelihood that they're going to do it again, extremely high, because you've interfered with these pleasure pathways, stimulating the response, the pleasure response, without actually having done the behavior that typically is supposed to be associated with that pleasure. OxyContin is a drug that's used typically after people have surgery. It's a painkiller. If they're trying to recover from surgery, it's very useful. What it does, it mimics a neurotransmitter that's very similar in shape to opium. And this binds to pain receptors in your body, and it binds to the receptor, but it doesn't trigger the action potential. And by binding to that receptor and then just blocking it, when you're supposed to be feeling pain, it just gets blocked. No matter what the release of neurotransmitter that is supposed to be stimulating pain, it goes away when people take OxyContin. Ecstasy is a drug that it gets abused by lots and lots of people. What ecstasy does is it increases serotonin production. So serotonin, more production causes the vesicles to be filled more. So for each release of the vesicles dumping serotonin into the synapse, you get more serotonin. It also blocks serotonin reuptake. When ecstasy was first discovered, people were talking about how maybe it would have therapeutic effects. Therapists wrote about it and talked about how they thought people could get insights into relationships and themselves and all that. And so there was a lot of interest there, but because so many people started misusing it, it quickly became categorized as a very controlled drug that you couldn't do research on very easily. In one just small study, some researchers looked at a bunch of primates that had been given ecstasy twice a day for 4 days. And then the study had ended and the animals were just kept somewhere at a animal rehab center. 8 years later, when the animals had died, the researchers looked at their brains and they found that the serotonin producing cells in the cerebral cortex, in a part that's used in learning, were still damaged, permanently damaged, as were serotonin producing cells in the hippocampus, part of the brain that is important for memory. So just from these 8 times that they had had ecstasy, these animals had these pretty dramatic and permanent changes. And so if you're interested in learning or memory, then that causes you to maybe think twice about that one. Let's look at more drug effects. Adderall is a drug prescribed to lots and lots of people, and it's very effective for ADHD treatment. But like many drugs, pharmaceutical drugs, even those that have been approved for usage and have a lot of success, we don't always know exactly how they have their effect. If you read the packaging on the material, all the warnings, they often will say, we're not really sure exactly how this has the effect. We just know that it does. In the case of Adderall, what we do know is that it increases the release of adrenaline. It increases the release of dopamine into reward center synapses. It blocks reuptake of adrenaline. So you've already released more and now you're not taking it back up. So you multiply the effect of it. It blocks reuptake of dopamine so that, again, you get an enhanced effect in those pleasure centers. It blocks reuptake of serotonin. So you also have enhanced serotonin functioning, and it inhibits monoamine oxidase. I've told you that when neurotransmitters are released into the synapse, they bind to a postsynaptic receptor, then they get released and reuptake occurs. But also enzymatic breakdown as a way of cleaning up the synapse so that the cell can function again. Monoamine oxidase is the name of the enzyme that breaks down both dopamine and serotonin. So if you have a chemical that can bind to monoamine oxidase in such a way that it can now no longer break down dopamine or serotonin, what happens? Well, you end up with more of those neurotransmitters in the synapse. You get an enhancement of the effect of those neurotransmitters in whatever parts of the brain you are having that happen. We don't know what else it does, if that's all it does, but it's a pretty good example of how targeted design of drugs allows us to interfere with normal neuron functioning at the synapse. In a lot of cases, this can allow us to have drugs that change the way we feel, that change the way we function, and many other things. So there you have it.